When graphing a linear equation, typically the slope and the y-intercept are used to help plot points on a Cartesian plane. It is also possible to create the graph for a linear equation using only the x and y-intercepts of the linear relation. Recall that the y-intercept is where a line crosses the y-axis. And specifically for a y-intercept, we find that the x-coordinate of the intercept is always 0. For an x-intercept, this is where the line will cross the x-axis. And we find that for an x-intercept, the y-coordinate of the x-intercept is always 0. So if we were to take a look at a graph of a line that is plotted on a Cartesian plane, in this particular graph, the y-intercept and the x-intercept are marked for us. If we look specifically at the coordinate point that is associated with an x-intercept, this particular coordinate point is at 0, 4. So the y-intercept, where the line touches the y-axis, it is crossing the y-axis at a value of 4. So if we were to count, this would be 1, 2, 3, and 4. But if we were to write the y-intercept as a coordinate point, this is specifically located at 0 and 4. So the x value is 0, but the y value is 4. On the other hand, with an x-intercept, this particular x-intercept for this line is located at 5 and 0. So if I were to count using the scale on my x-axis, 1, 2, 3, 4, 5. So it is located at a value of 5. But if we were to write this as a coordinate point, we would be saying it as 5, 0. So there is an x value of 5, but the y value associated with this particular x value happens to be 0. So for a linear relation, if you were given an equation, you could use that equation to algebraically determine the x and y intercepts. Once you have those two coordinate points, you could plot those points on a Cartesian plane, join them together with a straight line, and you can actually graph a linear relation that way. So in this first example, we have an equation given to us, 2x minus y equals 5. We are going to use this equation to algebraically calculate or determine the x and y intercepts. So let's start with the x-intercept. We know that when we are dealing with an x-intercept, the corresponding y value is going to be 0. So knowing this, I can set y equal to 0 in my equation. This means that wherever I see the letter y in my equation, I'm going to replace it with a 0. So I've recopied the equation, 2x minus y equals 5, and I'm going to go ahead and replace the y with a 0. Now, 2x minus 0 is essentially like saying 2x minus nothing. So if I were to simplify this, I could simply just write 2x equals 5. And now it's just a matter of solving or isolating for x. So in order to do that, I'm going to divide both sides by 2. And that's going to leave me with 5 divided by 2, which is a value of 2.5. Now, you could leave it as a fraction, and we are known to leave our answers as fractions. However, it's kind of hard to graph 5 over 2. So by turning it into a decimal, we get a decimal value of 2.5, and that's a lot easier to find on the Cartesian plane. And the last thing we're going to do is we're going to actually state our x-intercept as a coordinate point. So to do this, we're just going to write an open bracket. And remember, when you're writing a coordinate point, the x value has to come first, followed by the y value. So our x value is 2.5, and the corresponding y value, remember, was 0. We set y equal to 0, so I'm going to put in a 0. So this coordinate point of 2.5 and 0 is what I'm going to plot onto my Cartesian plane. So I'm just going to enlarge this a little bit. I'm going to go to my x-axis. Remember, my x-axis runs horizontally. And on the x-axis, I'm going to look for the value 2.5, which is located right in between 2 and 3. And so I'm going to take my pen and I'm going to put a dot at 2.5 and 0. So right about there. Now we can go ahead and calculate the y-intercept. So remember that for a y-intercept, the corresponding x value is equal to 0. So in order to solve for your y-intercept algebraically, we need to set x equal to 0. So it's basically the opposite of what we did when we solved for the x-intercept. So I'm going to go ahead and recopy the equation. And in the place of x, I'm going to substitute a 0. So 2 multiplied by 0 is a 0. So that's going to leave me with negative y equals 5. And then it's just a matter of solving and isolating for y. Remember that when you're not seeing a number directly in front of the y, there is still a 1 there. And in this case, it happens to be a negative 1. So we are going to have to divide both sides by negative 1, which will leave us with a y value of negative 5. So if we were to write this as a coordinate point, remember that our x value was 0 because we set x equal to 0. But our y value, which we solved for, is negative 5. So our y-intercept is located at a coordinate point of 0 and negative 5. So coming back to our Cartesian plane, I'm going to put a dot or a point on my y-intercept. So my y-intercept is located at 0 and negative 5. So that would be located down here on the bottom. So here's my red dot, and you can then join your intercepts together with a straight line. Again, make sure that you extend your line out a little bit past your endpoints and put little arrowheads on the ends of your line. So here's your line. So it is possible to create a linear relation on a graph using only the x and the y intercepts. So now it's your turn. Here is a brand new equation, 3x minus 4y plus 12 equals 0. You're going to follow the same steps and algebraically solve for your x and y intercept. Once you have your coordinate points, you can plot them on a grid, join them together with a straight line. So you can pause the video now and go ahead and solve for your intercepts, and then you can come back to the video when you're ready to check your answer. So remember, when you are solving for an x-intercept, you want to set your y value as 0. So I recopied my equation, and when I get to my y variable, I'm going to replace it with a 0. So if I simplify this, I know that negative 4 multiplied by 0 is 0. So my equation then can just be simplified to 3x plus 12 equals 0. So now by isolating for x, that's going to require me to collect some like terms. So what I'm going to do is I'm going to separate my terms by bringing this 12 over to the right-hand side. When I do that, that positive 12 is going to turn into a negative 12. And then to isolate for x, we're going to divide both sides by 3. So that leaves me with an x value of negative 4. Remember that you want to state your final answer for your x-intercept as a coordinate point. So if I were to turn this into a coordinate point, my x value is negative 4, my y value is 0. So negative 4, 0 is the point that I will plot onto my Cartesian plane. To solve for your y-intercept, remember that you want to set your x value equal to 0. So I'm going to recopy out the equation, 3x minus 4y plus 12 equals 0. And this time, in the place of x, I'm going to substitute 0. If I simplify that, 3 multiplied by 0 is 0. So that's going to just leave me with negative 4y plus 12 equals 0. I'm going to collect like terms, so I'm going to move this positive 12 over, which will leave me with negative 4y equals negative 12. And then to isolate for y, I need to divide both sides by negative 4. And by doing that, I will be left with an answer of y equals 3. Make sure you express your final answer as a coordinate point. So if I were to do that, I would get 0 and 3. Now that we have our two intercept values, I can go ahead and make my graph. So my x-intercept was located at a value of negative 4 and 0. So I'm going to go ahead and put a point at negative 4 and 0. And that's a green dot for you on the screen. My y-intercept was located at 0 and 3. So that would be located right up here. Once you've plotted your two intercepts, you can go ahead and join them with a straight line. And once you do that, you should have a line that looks as so. Now let's take a look at some of the work that we can do with intercepts that doesn't require any graphing. The second example asks you to determine the slope of the line that has an x-intercept at negative 5, 0 and a y-intercept at 0, negative 2. Remember that there are lots of different ways that we can calculate the slope. However, there is one exact method that we can use to find the slope that requires the use of two coordinate points. And that would be the slope formula, y2 minus y1 divided by x2 minus x1. So the first thing that I want to do is look at my points and label them x1, y1, x2, y2. So it doesn't matter which one you designate as being 1 and 2. So I'm going to keep my x-intercept as x1, y1, and my y-intercept will be x2, y2. Once your points are labeled, you can go ahead and substitute them into the formula. So my y2 would be negative 2 minus my y1, which is 0, divided by my x2, which is 0, minus my x1, which is negative 5. Be careful with your signs. Make sure you encase all of your negative numbers in brackets, especially when you are subtracting. So if we subtract in the numerator, we've got negative 2 minus 0, which is negative 2. And then in the denominator, we have 0 minus negative 5, which is a positive 5. Now you could go ahead and divide negative 2 divided by 5, but I think we're just going to leave our answer for slope as a fraction. Negative 2 over 5 does not reduce in lowest terms, so our final answer for the slope is simply going to be negative 2 over 5. In the final example, the slope of a line is negative 2. The y-intercept of the line is 3. They ask us to then determine the x-intercept. Once you know the slope and the y-intercept of a line, remember that those two pieces of information are essential or critical to help you determine the actual equation of the line. And the equation of the line is given by y equals mx plus b. Remember that slope is represented by the letter m, and the y-intercept is represented by the letter b. So if we know the slope and the y-intercept, we could simply just stick them into our equation template. So by doing that, that would give us y equals negative 2x plus 3. So now that we have an equation, we know how to determine an x-intercept. We know that we can find an x-intercept by setting y equal to 0. So in the equation that we just came up with, we are going to replace the letter y with a 0. And now we can simply go ahead and solve or isolate for x. So to do that, I'm going to start by separating my terms, and I'm going to take this negative 2x and bring it over to the left-hand side. If you really wanted to, you could choose to take this positive 3 and move that instead over to the right-hand side. So I would be left with positive 2x equals 3. And to isolate or solve for x, I'm going to have to divide both sides by 2. And in doing that, 3 divided by 2, well, if I really wanted to, I could leave it as a fraction. Or if we really wanted to put it as a decimal, we could divide. And 3 divided by 2 is 1.5. Remember that you should always express your intercepts as coordinate points. And so I'm going to write a therefore statement that has my x-intercept given as a coordinate point. So I'm going to say, therefore, the x-intercept is 1.5 and 0.